Thank you, Dave, and thank you, everyone, for coming today. It's a pleasure to be here. Dave, if you're anxious, there will be no political comments from me. So that ended with Gordon. But again, thanks for the chance to be here today. I want to talk today about some work that not only myself, but a team of us have been working on the last 4 to 5 years that started with trying to understand market signals in the value chain and culminated with a paper that was published that brought an economic component to nutritional analysis, trying to quantify the value of soybean meal in diets, not just on crude protein, but as we look at increasing amino acid concentration and energy concentration, applying what that means in a diet formulation in terms of the specific value of intrinsic quality characteristics. So I want to get to that study, but just for context, to provide some information, I want to break this presentation into 2 components. So one, just looking at the value chain and providing an understanding of what's happening in the overall value chain in the U.S., but then getting into what that means in terms of what we found out from some of the information we gathered into this analysis that allowed us to provide a framework for quantifying soybean meal value. This is a very simplistic version of the soybean value chain, but just to give you kind of an overview of what we're looking at and some of the challenges that we're facing. Again, it's a lot more complicated than this. There's more actors, but just to go through this. So geneticists, producers, elevators, processors, and end users. So each one of these segments of the soybean value chain is motivated by different things. They're responding to different economic forces. They're responding to different market signals. So on the upstream side of the supply chain, geneticists, producers, it's all about maximizing yield. Right? Farmers, producers, they increase their revenue by producing more, capturing a higher price when they can. Geneticists respond to that by providing varieties that maximize yield. That's all very logical, very rational within each segment of the supply chain. Elevators, it's managing basis, supply and demand. Processors, Gordon just talked about that in terms of crush margin. It's really trying to minimize the cost, but also maximizing what they can get for the product, the meal or the oil that they're producing. And then end users. So if yield is the focus at the upstream side of the supply chain for you yourselves and the industry as end users, it's about what's in the ingredients that you're using. It's about the composition. That doesn't necessarily get relayed back down to the supply chain. And I'll go through some data that shows and actually quantifies some of those relationships over time. So this is just a pretty simple yield chart of soybean yields over the last 25 years, which shows a pretty nice trend increase in yield over time, about 1/2 bushel per acre a year over this time period. So again, as we think about that upper portion of the supply chain, you could call this a success in terms of geneticists creating varieties that maximize yield, farmers maximizing the yield that they get based on the varieties that they're producing. We take that in terms of overall value. Again, good news, it's increasing over time. Again, it's volatile here because it's a function of both price and yield, but we had a record value of the soybean crop a couple of years ago. Again, increasing, that's great news. The problem is, as we look at the products that are created from the soybean, the meal and the oil, specifically the meal here, we've seen opposite trends. So over the same period of time, this is looking at estimated soybean meal crude protein. So we have not seen corresponding increases in soybean meal crude protein over this same period of time, even though we have seen increases in yield. So as a nutritionist, this means more volatility. It means more challenges in terms of managing the ingredients that you're making available in your diet, potentially more costs or bringing in more costly ingredients to supplement or ensure the performance of the animal. Part of the challenge when we think about communicating back through that value chain, so information flows both ways, upstream and downstream. One of the challenges is the focus strictly just on crude protein. So if we look at how soybean meal is traded, these are just the NOPA specifications. They're typically, soybean meal sales are based on some level or minimum crude protein content. The challenge is that that doesn't necessarily tell you everything there is to know about the meal. It's not just the crude protein again, but what's in that crude protein in terms of the amino acid content. What does it mean if we're feeding a particular soybean meal in terms of changing energy content as well? So it's not necessarily fully accounting for the true value of what that meal is for an end user in making formulation decisions. Along with that, if you think about a slightly decreasing trend in that crude protein over time, we've seen alternative sources of protein come into the diet over time. So this chart is just showing, again, this is back to 1990, so a longer period of time, but the pretty consistent use of soybean meal over time, but the introduction of DDGs as that came available as a feed ingredient, along with synthetic amino acids, were overall, over time, feeding more of these protein sources. But the question is, what would that market share for soybean meal have been if we didn't see those similar slight declines in crude protein and meal, and we did have some increase like we see on the yield side? So part of this is trying to understand, can we quantify what that differential is and what could it have been, and trying to understand what the dynamics are. So Gordon had some similar numbers. This is looking at just consumption over time, just to give some context for what's been happening with soybean meal consumption in the swine and poultry industry. There's other species that are presented here in this chart. But again, over time, slightly increasing, but the allocation of soybean meal by species is changing. So it's growing in the poultry sector. It's slightly declining in the swine sector, and dairy is increasing recently. So again, some of these dynamics, as we think about the intrinsic quality of the ingredients we're using, is how much of that is a function of these changing dynamics within the industry. The good news is, regardless, and Gordon talked about this too, there's lots of meal in the market, there's going to be lots of demand, and what this chart is showing is, and it's an economic principle here, as we increase our per capita incomes, our appetite for meat increases. So these are just a select few countries to show that trend as we, on the x-axis, increase incomes, mostly in developing countries, our meat consumption increases. So increasing demand for meat protein, increasing demand for soybean meal, that's all good news. And part of that is, again, what's the potential for meal in the future if we consider all of these other factors at play? So I want to go back to this depiction of the soybean supply chain. And again, acting rationally within each of these segments of the supply chain. So part of what our initial work was talking with each one of players within each of these segments and trying to understand, how do you make decisions? What influences your decisions? How do you determine and define value from your perspective? And the issue is they're all kind of different. And what that leads to is one flow of information in terms of market signal that's basically a flow of volume. Upstream participants are trying to maximize volume in terms of the quantity of product that's moving. The challenge is, again, from the end user perspective, it's all about compositional information and meeting the nutrient requirements of whatever's needed for the animal that's being produced. So our challenge of what the group is to come up with an economic value, because everyone understands dollars and everyone is motivated, incentivized, and responding to economics. And so if we, as end users, look at the composition and that's what's driving value for us, driving decisions, we need to come up with a framework to be able to quantify in dollars and cents what that quality differential means. So taking more from a volume focus downstream back to a market signal that's focused on quality and composition. This led to this study that was published last summer, titled Quantifying the Value of Soybean Meal in Poultry and Swine Diets. So again, a big part of this was improving communication back through the value chain, trying to change the discussion around what the primary determinants of end user value are, to try and get individual members or segments of the supply chain better oriented and aligned around what do customers actually need and require. So creating value from the end user perspective, hopefully then taking a message back through the supply chain in economic terms that everyone could understand. So part of the methods of this project was, the objectives were to quantify soybean meal using amino acids and energy. So again, trying to move the conversation beyond just buying and selling based on crude protein, but looking at soybean meal in terms of both what happens if we have increasing amino acid concentrations and energy values. Again, a purpose was to raise understanding and application of those soybean meal values. So if you're at the front end of the supply chain, and again, you're a producer, you're not doing anything wrong, you're trying to maximize your yield, but how can we communicate what that means to that end user who's actually buying that soybean meal? If we can come up with a common framework, a common message, then that improves our value chain communication. A little bit on the methods. We analyzed soybean meal samples using NIR, tested them for moisture, 11 amino acids. Our goal was to use that data to create 5 different soybean meals. So 5 different soybean meals, 44, 45, 46, 47, 48% crude protein, some sense just to keep it nice and simple, but also to be able to pretty clearly demonstrate for a 1% increase in crude protein, and I'll get into the associated amino acid concentrations and energy values. If we use that in diet formulation, we come up with results that allow us to do some of this estimation. So we collected data, we did the analysis, we did some regressions. I'll show those here in a little bit. Actually, Dr. Dean Boyd did those for us as part of this group. And then we did an exercise. So used least cost formulation software to calculate the cost of the diets. So this included 4 phases of swine production, 3 phases of poultry production using representative diets in the US, ingredients that would typically be available on a regular basis, and ran the formulation based on a 3-year market year average price for each of the ingredients. We wanted to remove all variation as a function of price, so we used a 3-year average. Ran the formulation, the only ingredient we changed was using one of those 5 different soybean meal types, the 44, 45, 46, 47, and 48. Based on the results we're getting from the formulas, which included diet composition, diet cost, specifically soybean meal utilization, came up with a formula to quantify what that meal value is as we change that crude protein and associated amino acid and energy values in the diet formulation. Again, to get to that economic value that says on a $1 per ton or $1 per metric ton basis, what does increasing these intrinsic quality parameters mean in a dollar basis? This is just showing the predictive values of the amino acids that we use. So a key component of this analysis is that the amino acid concentrations and the energy values were increasing as we went from 44 to 48% crude protein. Use net energy on the swine diets using regression equations. Again, the key component here is that net energy for swine increased as we went from increasing crude protein concentrations, again, and the associated amino acid and concentrations increased as well. On the metabolizable energy for the poultry formulas, again, same thing. A key component here is that they were increasing as we increased crude protein from 44 to 48%. Getting into some of the results, average diet costs. So as we did the formulas, again, the only change we made within the formulation was the individual variant of crude protein soybean meal that was included in the diet. Similar trends across all 4 phases of swine production and 3 phases of poultry. We looked at, I should have mentioned this before, on the swine side, lactation diet, nursery diet, grower diet, and a finisher diet. On the poultry side, we looked at a broiler finisher, broiler grower, and a layer diet. So the results that are shown here are just averages by the species. But in general, the trend was as that crude protein, we've got the lysine shown on the chart here just as an indicator of what's happening with the amino acids. As that increased, overall diet cost decline for both swine and poultry diets. And inclusion tended to decline as we increased that soybean meal crude protein, again showing the lysine as an indicator of the amino acid concentration. So the more value that was in that soybean meal as we increased from 44 to 48, the less meal that was required. But in general, more value, less diet costs, more value to be attributed to the soybean meal in the diet. The relative soybean meal value, this is, again, trying to attribute based on how much soybean meal used as we went from each individual crude protein variant, in addition to what changes were made in the diet cost. We're able to calculate what's the value of that meal in the diet. So our base price, we used 48% crude protein as the base meal and compared the other ones to that. So what this is showing is there's the same value here, $358 per metric ton on that 48% crude protein value, but then we reduced it from there to get to what would the value of a 44% crude protein meal be in these diets, attributing the individual composition numbers to those crude protein values. So as you see, relative value increases. So this is our dollar per metric ton basis that we can attribute to soybean meal based on its composition. Increased in both the swine and poultry diets across all 5 soybean crude protein variants. To just summarize, I guess on an average basis for relative value, a nice way to think of this, again, is why we did it on 1% increments when we did the soybean meal variance in our formulation exercise. We saw that relative soybean meal value, dollar per metric ton, is what's shown here for each 1% increase in soybean meal crude protein. Increased $10 on the swine diets and $12 per metric ton on the poultry diets. So again, this was using, when we first did this analysis, it was a couple years ago, using a 3-year marketing year average prices. So we recognized that markets are volatile, a lot of things change. To make this credible, we got to do it a lot to make sure we're understanding how changes in prices impact the analysis. Our most recent analysis looked at upgrading the full most recent marketing year average price. So what this table is showing is looking at the analysis as we look at rolling it over and using updated ingredient prices. So the analysis that I just showed you in those results, the $10 to $12 per metric ton benefit on soybean meal per 1% increase in crude protein. That first column is the original prices, and I'm just showing now corn, soybean meal, and fat prices. Those changed a lot over the most recent period. If we look at that 3-year marketing average, soybean meal up 20%, corn up 60%, fat prices really increased. Again, this is not the current marketing year. This is through 22-23, so recognizing if you think that chart that Gordon just showed, soybean meal prices have declined. But just to give a sense for how variation in prices change, we reran the formulation, and the value increased over that period of time, so from $10 to $16 on the swine diets for every 1% increase in soybean meal, and $19, it was $12 on the poultry side. So recognizing prices matter, and the volatility of prices matter in this analysis too. But a big goal for this analysis was providing the framework. This is just one way to do this, recognizing that individual situations and practice are going to be different, ingredients are going to be different, how formulas are set up are going to be different, but the framework holds in terms of using your own individual information, your own individual ingredient prices, and being able to have an equation or an estimation process for how do we quantify this relative value of soybean meal based on its intrinsic quality characteristics. A new part of this analysis that we just had published last month was adding the environmental impact. So this is becoming, as Gordon mentioned, with the CI scores and policy driving a lot of what's going on in the market, trying to add to this analysis an understanding of what the environmental impact is. Before was the economic impact as we looked at composition, again, increasing amino acids, increasing energy. We wanted to understand if we could attribute different environmental impact coefficients to ingredients and run the analysis through the formulation, can we come up with a framework to quantify, for instance, what I'm showing here is greenhouse gas emissions or other common environmental factors or water use or energy use. So we use publicly available sources that use life cycle analysis models that are the best available information in terms of science-based numbers for coefficients for greenhouse gas emissions attributed to the individual ingredients that we made available in the formulation. So we ran our diets, calculated greenhouse gas emissions here, and based on our numbers and our analysis that we used, it did show a reduction in greenhouse gas emission, again, for every 1% increase in crude protein. So the value of the meal increases as that composition of the meal and quality increases. We also get, based on the numbers that we have available, a reduction in greenhouse gas emissions as that quality or that intrinsic composition factors of the meal increases as well. So our analysis showed in swine a little less than 5% decrease in greenhouse gas emissions for every 1% increase in soybean meal crude protein, about a 5.5% decrease in poultry diets for every 1% increase. So this kind of combines two things. One, the economic component of assigning a relative value and a dollar basis to that compositional difference, but also bringing something relevant to the industry now and understanding if we want to formulate diets based on environmental information that we have available, recognizing that it's still new in the industry, there's still a lot of kinks to be worked out in terms of modeling and methodology and standardization. But again, this is a framework that could be used when new information becomes available that we can use to estimate some of these impacts. So just to review everything, and these are not news to anyone in this audience, but I mean, soybean meal is a high quality feed ingredient. It's still the most economical source of amino acids as an ingredient in the diet. Part of what we tried to demonstrate with this work was that there is soybean meal value beyond just what we typically talk about of crude protein. So beyond the crude protein, trying to come up with an estimation of what's in that soybean meal, what's happening as we increase amino acid concentrations and energy. Our results showed that increasing soybean meal crude protein and energy does increase that soybean meal value. So as we increased, from our analysis, we looked at 44 to 48%, that value increased. And what this allows us to do is come up with a way to have common knowledge and understanding along the supply chain. So again, as we think back to that simplistic description or that picture of the value chain and having conversations with individual segments within that value chain, this allows end users specifically to say, here's what matters to me, here's how I determine value, and from a dollar perspective, here's what that is, and that creates better alignment around the supply chain. So with that, thank you for your time, and I will turn it back over to Dave.